how AI works. And of course, in this, I will be mostly talking about the math concepts around how AI works. But I do want to give some brief descriptions and all about AI models in general. So, of course, there are many different AI models. For stuff like image recognition, we can use it for like just stuff like image recognitions. Like if I have a picture and it has 9 on it, and now I need my AI to tell me, oh, this is 9. And the way the AI does it and all, there are many different ways to do it. We have many different models that can do it. MLPs, CNNs. We even have eye transformers. Transformers. There are many things like ResNets. There are so many different ways, or so many different AI models. Now, chances are you don't actually know what most of those mean. And so I'll give you a brief description of how AIs just work in general. AIs are no more than just a mathematical function. Just imagine it as a really complicated mathematical function. So if I give something like 3 into the AI, it does a bunch of stuff, and say it outputs 6 now. And say for 2 it outputs 4. Now this isn't a very, like, if you can see the pattern, it's not too difficult of a mathematical function, because all it's doing is just multiplying it, right? So the point of this is just to, an AI is, it's pretty much just taking an input and giving an output. And yeah, that's basically all an AI is. And of course, I'll talk about some of the math concepts we need if we want to really go further into AI and really get into it. And so one of these important ones is that you need to know algebra, firstly, just how functions work and in general. And well, a little bit of graphing knowledge and all, but what you really need is something like linear algebra, which I'll give you small recaps on once we really get there. But what we also really need is multivariable calculus. And it's fine if you just know regular calculus, just some basic how differentiation works and all that. I have a series on that. There are many, and for linear algebra too, there are many amazing resources out there. And so it is with calculus. Calculus is used for making the AI learn. Because remember, we have to change this function to actually do it. Like for ChatGPT, you take in an input and it gives out an output, which is the thing that it shows you. And so it's really got to have, you got to change the function, because it's not a very simple function and you have to change it a lot. And so calculus is used to make the AI learn, and this changing of the function is what we call learning. And linear algebra is used for pretty much everything. It's mainly used to simplify down the concepts. You don't need linear algebra, but honestly, I will be showing linear algebra methods, because without it, it gets really complicated really fast. So linear algebra is used not just for learning, but also for just everything. And so the linear algebra and calculus are quite important stuff to know for this series. And okay, so let's go into how AIs just kind of work in general. A little bit more, a little less general maybe. Okay, so inside an AI is what we call a bunch of learnable parameters. And I'll talk about a specific type of machine learning model called MLP, or a fully connected layer, or a dense model. There are many names for it. I'm just gonna call it this for now. And in this function, you put it in, and you take it out. So it's 5 now. And what happens inside this function? Well, in this function, of course, for an AI to learn, you have to be able to change some stuff in the function, right? And the things that you change in this function are these parameters called weights and biases. So we have some weights, which is just a lot of numbers that you can change, and some biases, which is also just a lot of numbers you can change. However, writing it like this, it just doesn't seem very, like, you can't really visualize any of this. I mean, how does changing the weights change anything? Like, how does the AI actually go forwards with doing any calculations? And so that's why I will show you a new way to represent this model, because, well, just putting f of x and then suddenly it all gives an output doesn't really sound very cool. So the way we're going to do this is by using these little circles called neurons. And the neurons, it just takes in the inputs and it gives out the outputs. So over here, let's say you got a 2 from in here, a 3 from in here. What's the neuron going to be? The neuron's going to be 5. It's going to add them. And it's going to broadcast the 5 over that way, and that way. It's going to broadcast the 5 over. So maybe there's a neuron over here willing to receive it. And maybe it's also receiving a 3 from another neuron. And now this neuron is an 8. Right? So a neuron takes in an input, it adds them, and for its output, it just gives that exact same thing off. So here's how an MLP basically works. I'll just give one with an input layer and an output layer, because we usually split these up into layers because it's a lot easier to do math when layers exist. So maybe there's 2 input layers and 3 output layers. Now the way this works is that the input layers is just basically the input. So maybe we inputted 2 and 3. And I'll write it like this because, well, it doesn't really mean that much more than we just put in a 2 and put in a 3. And so what is the output going to be? Let's try and think about it. And so in this case, there are 6 total connections, right? And so the idea behind this is, well, if I just take in this neuron input 2 and it goes in there, oh, and so let's just say the 2 comes here and it goes through and it's getting a 2 from this end, right? And so 3 it starts here, goes and it's getting a 3 from this end. So what is this output going to be? Oh, it's going to be a 5, right? Because 2 plus 3 is 5. And so our first output will be a 5 on the top. Remember, we're expecting 3 outputs. That's why we have 3 in the output layer. And so over here we have 2, okay. We're going to go here. It's going to take a 2 from here, remember? It's going to take a 3 from here. And if you notice, it's also a 5. You do the same thing over here. 2 coming in from here. And a 3 coming in from here because they're coming from this and this. And we get a 5 again. So that's not very helpful because, well, firstly, this is just a fixed, pretty much nothing. And AI needs to learn, and for that you have to be able to change something. And unfortunately, we will not be changing the layers. That is it's not cost effective at all. The way we usually do it, and here I'll show you, is with a system called weights and biases. I'll show you what that means. So remember, the input neurons, we start here, we get 2 and 3. And so the idea is, whenever it goes through a line, it gets multiplied by some number. And the number is determined by the line. So say for this line, that number is 1. This line, the number is -1. And this line, the number is 2. Because, well, if those numbers don't exist, the AI can't learn anything. And these white numbers, the AI is allowed to change them. And I'll show you how we change them to complete the task that we want to do. Because these AIs obviously have to do something. They're not just sitting around calculating numbers. And yeah, I'll show you that. But I'll show you that in more later episodes. But the way it works over here, 2, and we go 2 times 1, okay. So it's getting in a 2 from here. It's getting -2 here. and it's getting a 4 here, because remember 2 times 2 times -1, right? And okay, so now what is this 3 giving out? Well, so of course we have 3 more lines. So now we're going to have to I'll write this in purple. Why not? Alright, so we have 3 more lines. So that's 3 more numbers for our AI to be able to change to make our AI better and better and better. And so maybe this number is -1, this one is 2, this one is -2. And so our inputs in here will be -6. Sorry, our output, it's going to output after the weight. It's going to be -6. 3 times 2, that would be 6. And over here we have 3 times -1 will be -3. Remember, it's getting 2 and -3 in, so it's going to be a -1. It's getting a -2 and a 6. It's going to be a 4. And so we just calculate it like this. We get a 4 from here, -6 from here, -2. And now look, since now that we actually have a system for changing our weights and biases and all that. Alright, I'll explain what a bias is later. But now that we have a system for that, we go from the input layer to the output layer, and now each line has its own weight that, depending on the task, our AI can change. And this is like the core concept of MLP. Now, in an MLP, there's also something called a bias. But a bias is, I guess, simpler. Each neuron has its own bias. And instead of multiplying, we actually add those. So let me explain. Except for the inputs do not get biased. So this neuron, say its bias is 2. So we have to add 2 because that's the bias of this neuron. Maybe this bias is -1. So we subtract 1. And maybe the bias for this is +2. So we add 2. So the final result, after we take into account the bias, is going to be +1, 3, 0. And so that's the idea. We go from the input, we put in an input, and the input is basically just what we want to input into AI. Maybe like the prompt. Maybe you turn the prompt into a bunch of numbers, and then you put it through, and it goes through all of these weights and biases, and it gets to the output layer. And of course, there's a lot more, and I'll talk about stuff like hidden layers and all next time. So I'll see you on the next video. And of course, remember, AIs, all they are, you put in something, and it goes through all these lines and all, and it goes to the next neuron, output, and ta-da, and then you add a bias for each neuron, except for the input neurons, and ta-da, we have an output. And you might think this won't learn anything complicated. How is this going to, I don't know, tell what a number is based on an image? And not yet. Although right now it can kind of do it, maybe with like some 30% accuracy. But, well, we will be able to make this a little bit more complicated and put a fully fledged MLP that can get stuff like 96% accuracy. But that's going to be saved for our next video. So see you until then. Bye.